Hello, this video is a short introduction to projections of vectors. So one very naive way to think of what a projection is to think about a shadow. So suppose you're given two vectors, a vector A and a vector B. A projection of the vector B onto A is sort of the shadow of this vector B onto the line which is passing through the vector A. Notice that if theta is less than pi over 2, the projection of the vector B onto A is a vector which is pointing in the same direction with the vector A. If theta is equal to pi over 2, that is, if B is orthogonal to A, then one expects the projection to be the zero vector. In this picture on the right hand side, we see that theta, which is the angle in between A and B, is greater than pi over 2, and the shadow, the projection of the vector B onto A, is pointing in the opposite direction of the vector A. Now we'll show you how to compute the components of a projection of a vector. The formula is quite simple. This notation here denotes the projection of U onto V. And basically, in order to compute the component of this vector, one needs to take the vector U and dot product the vector U with the unit vector which is pointing into the direction of V. Notice that U dot EV is going to be a scalar. Now, we will scale the unit vector in the direction of V by this scalar that we just computed. So, here is an example. Suppose that U has for component 2, 3, 1 and V has for component 4, 3 and 2. And we want to compute the projection of the vector U onto the vector V. Step 1. We first compute the unit vector in the direction of the vector V. How do we do that? We scale the vector V by 1 over the magnitude of the vector V. So one obtain 1 over square root of 16 plus 9 plus 4 times the vector of component 4, 3 and 2. You might want to pause the video for a few minutes just to check these computations. So, by scaling this vector 4, 3 of component 4, 3 and 2 by 1 over the magnitude of V, which is now square root of 29 over 29, one obtain these components for the unit vector pointing in the direction of V. Now, in the second and last step, we first compute the dot product of U and the unit vector pointing in the direction of V. If this is done correctly, one should obtain 19 times square root of 29 over 29. Again, you might want to stop for a few minutes, pause the video, and check these computations for yourself. Once you obtain the dot product, then all you have to do is scale the unit vector pointing in the direction of V by the scalar here. By scaling the unit vector pointing in the direction of V by 19 times square root of 29 over 29, we obtain the vector of component 76 over 29, 57 over 29, and 38 over 29. Again, you might want to pause the video for a few minutes and check these computations for yourself. Thank you.